Now here is a composite exercise for us, and this time we're going to take this shape. Well, we're going to generate this shape first. Let me make this shape for you, and we're going to find its surface area and its volume. So I'm going to take this odd-looking shape and I'm going to spin it around. Aha, and there I go. I've got myself a cylinder with a hemisphere removed from it. Paint it up a little, make it look a little more sensible. All right, that's what I'm taking out of the cylinder. So the blue equation is going to give us the surface area, and the surface area of this figure, well, let's look at it. I've got the surface area of a hemisphere. That's half the surface area of a sphere. It's actually on the inside of the sphere. And then I've got the, if you will, the label of the cylinder. We call that the lateral area of the cylinder. And of course, I've got the area of this base, which is a circle, pi r squared. So I've got three components to add together for surface area. Now, in the brown, volume, much easier. Got myself a cylinder. Volume of a cylinder, that's straightforward. And I'm going to subtract half the volume of a sphere. And as you can see in the brown equation, just two components. And let's flip to another page and we'll do the math. All right, let's do the calculations for the surface area and volume of this figure. And as we said in the 3D mode, half the sphere, well, that's going to be 2 pi r squared. Lateral area of a cylinder is circumference times height, which is 2 pi r h, and pi r squared for the circle. I'm going to combine the first and third terms. Aha. So 2 and 1, I've got 3 pi r squareds. And now let's just go right to the substitution. I'm going to substitute in magenta would be the radius, and then green for the height of this particular figure. And when I simplify this, remember I'm squaring this 3.3, multiplying by 3. Leave it in terms of pi. And I've got a 7 times 3.3 times a 2 here, also in terms of pi. Notice it's time to think about those units. I've got inches times inches. That's going to be square inches. So there I go. I've got square inches here. And now I'm going to multiply by a factor of pi to the nearest hundredths, 247 and 78 hundredths square inches. Let's go to volume. I'm going to perform the substitution, pi r squared h for the volume of a cylinder, minus half a sphere, which would be 2/3 pi r cubed. I'll do my substitution again, my radius in magenta, and my height in, my height in green. I should have said earlier, you notice that, of course, it's important that the radius of the sphere is the same as the radius of the cylinder. When we do the arithmetic here, remember I'm squaring this 3.3, I'm cubing this one. So thinking about units, I know I'm going to get cubic units. So I've got square units here times linear units. So I've got these two expressions. The one on the left, or the first one, this is going to be the volume in terms of pi of the cylinder, and I'm going to remove from that the volume of the hemisphere in terms of pi. There it is in terms of pi. I'm throwing those units in there, cubic inches. Now just multiply by your pi key, and there you go. 164 and 22 hundredths. Well, let's start by building the solid here, composite solid, and this is exercise number 22. So we're going to start with this cylinder with a radius. We've got a circle here with a radius of 5.8. Let me make this a little bit smaller, move it down here, and we're going to extrude this to a height of 14. So there we go. Oops, I said 14. And now that we've got this cylinder extruded and a semicircle drawn, it can be revolved around the blue axis. So let's do that. And let's see what we get here. There it is. And now we can look at this solid. You can see it very clearly here because I've got the, for surface area, again, I'm going to have that rectangular section, the lateral area of the cylinder, that is. I've got the hemisphere, or half the sphere, and I've got the circle on the bottom, just like we did on the last one, exactly like it. Where it's different is volume, because the volume, I've got the volume of the cylinder. That's simple. And instead of subtracting, looking like a silo or something, I'm going to add this. So it's going to be the volume of a cylinder plus 1/2 the volume of a sphere. And again, just like last equations, you see half a sphere is 2/3 pi r cubed for volume. And half the, just like half the surface area is 2 pi r squared. So let's do the numbers. And we'll go through this one a little bit faster. It's just like the last one. You can freeze it any time you need. Surface area, again, 3 parts. The hemisphere, the lateral area, and the circle. And we know 2 pi r squared for a hemisphere. The lateral area, 2 pi r h, and pi r squared for the circle. I can combine the first and the third terms. I substitute in there for radius and height. Again, the radius is common to all the figures. And in terms of pi, that's what I get for the two values. And here we go, adding them all up in terms of pi. My surface area I've got right here in square feet. You notice I kept track of that. I was when I squared the 5.8 or 5.8 times 14, I was generating square feet. And times pi, using the pi key on my calculator to the nearest hundredth, 827 and 24 hundredths. In the volume side of things, unlike the last one, we are now adding that half sphere. So there's cylinder plus half a sphere. Our direct substitution. Remember, you are cubing this radius. You are squaring this one. That's going to generate cubic units. And you can see them right here. We have cubic feet. In terms of pi, I've got the numbers here. I'm going to caution you on this one. I rounded that one. I actually kept them all the digits alive in my calculator. So when I did that, I'm just reporting to the nearest hundredth here. But I kept a few more digits so that when I multiplied by pi, I got this answer. If you truncate there, you'll probably get 19 hundredths. But that's pretty good in my book. So here you go, 1,888 and 21 hundredths cubic feet. And the final figure for this film, this will be exercise number 23. I've got the old ice cream cone. It's like pistachio. Yum. And this one will be a little bit simpler because, of course, I only have 2 terms as far as the surface area. I've got the curved hemisphere in the green, and then the tan ice cream cone. That's going to be the lateral area of the cone. Now, the one thing to watch out for, I left you a little strip there, you notice. I'm not using the height when I'm finding lateral area of cone. I'm using slant height. Remember that, the slant height. How long is this little pink strip running down there? So be careful. Remember to use that. That's the only word of caution I've got there. As far as volume will be straightforward. It's going to be half a sphere and the full volume of the cone. Well, now that we've seen the 3D version, let's, again, looking at this static model, let's calculate these surface areas. We're getting good at this. We have half the surface area of a sphere plus the lateral area of the cone. Remember that circle on the inside is not exposed. We substitute the equations, 2 pi r squared plus pi r L. L is slant height. Slant height, that is not given. No, it is not. You must calculate that. I can see a little right triangle right there where the 2 legs of that right triangle, we solved for that with the Pythagorean theorem, and I got about 13.5. So we can do all the substitution. This time I did not factor because I want you to see it this way, because each of these components, this first part is, of course, the sphere, and the second part, the lateral area of the cone. I'll answer them in terms of pi, then I'll combine them. So I've got about 114.26 pi, multiplying by pi, 358 and 97 hundredths square centimeters for surface area. And the volume of the 2 pieces here, again, the volume of the cone, the complete volume of a cone, and half that of a sphere. A cone, as you recall, is 1/3 pi r squared h, and a sphere is 4/3, so we'll take half of that, 2/3 pi r squared cubed. We'll do the substitution directly into those two formulae. This time I am using the 12.6 because I'm finding volume. Volume, I want the height of the cone. And after all that substitution and a lot of arithmetic, remember I'm squaring this 4.9, but I'm cubing this one. So come see me if you're having problems with the calculator, but you should have gotten these two expressions, or these two terms, which can be combined. The cone, you can see bigger than the sphere. I'm going to combine them in terms of pi, multiply by pi, 563 and 21 hundredths cubic centimeters.